You know, there's something we all experience every single day, something so fundamental to our lives that we barely even notice it happening. Our planet's rotation. It gives us day and night, it shapes our weather, it even molds the ground we stand on. But have you ever stopped to wonder what would happen if it didn't? What if that constant, reliable motion just stopped? Well, let me tell you, the consequences are way more extreme than you could ever imagine.
So to really wrap our heads around this, we need to talk about speed. Right now, if you're standing anywhere near the equator, you are moving through space at a blistering 1,670 kilometers per hour. That's actually faster than the speed of sound. Our entire world, the atmosphere, the oceans, you, me, everything, is spinning along in this incredible cosmic dance.
So what if that incredible planet-shaping motion just came to a screeching halt? Well, the answer really depends on how it stops. So we're going to look at two very different scenarios. First, a sudden, catastrophic stop, and then something much, much slower. Okay, but before we slam on the brakes, we really need to appreciate what that spin is doing for us right this very second, because it's about so much more than just day and night. Earth's rotation is like a master architect, constantly shaping our world in ways that make it livable. And what's really fascinating is how all these effects are linked. That constant spinning creates a centrifugal force that literally pushes the planet's mass outward at the equator. It's why Earth is about 21 kilometers wider there than it is from pole to pole. This also slightly reduces gravity, and, this is the big one, it creates a force that is the master conductor of all our weather and ocean currents. And that force is called the Coriolis effect. The easiest way to think about it is that the planet's spin gives a little sideways nudge to anything moving across its surface, whether that's wind or water. This is literally the reason hurricanes spin. It's why we have these huge, predictable weather patterns like the trade winds and jet streams. Without it, our planet's climate would be completely unrecognizable. All right, let's get to our first thought experiment. Now, this scenario pretty much breaks the laws of physics, but it is the absolute best way to understand the insane amount of energy we are dealing with. So imagine some cosmic force hits the brakes, and the solid Earth stops spinning. Instantly. To understand what happens next, you only need to know one word: inertia. It's that basic rule of physics, right? Newton's first law. Things in motion want to stay in motion. You feel it when a car stops short and you lurch forward. Now just imagine that on a planetary scale. So, the solid ground beneath your feet has stopped, but everything on top of it hasn't. The oceans, the atmosphere, every building, every tree, all the topsoil, it all continues hurtling forward at over 1,600 kilometers per hour. The surface of the Earth would be scoured clean by a planetary-scale sandblaster. The result would be a cataclysm that's hard to even describe. The atmosphere would become a hypersonic wind, scraping continents bare. The oceans would rise up into a global tsunami that would wash miles and miles inland, wiping out everything. The friction alone would generate so much heat it would literally melt and reshape the landscape. So yeah, the conclusion for this first scenario is pretty stark. It's an unsurvivable, extinction-level event. Nothing on the surface could possibly withstand that initial shock. Civilization as we know it would be gone, in an instant. Okay, so the sudden stop is a total physics nightmare. But that's not the only way this could go down. What if, instead of an instant catastrophe, the Earth just slowed down, gradually, over millions and millions of years? Now this presents a completely different kind of challenge. It stops being an inertia problem and becomes a massive climate problem. Now, this second scenario is way more plausible. It's kind of how planets can naturally change over geologic time. So here, the Earth slows down bit by bit until one side is permanently facing the sun. We call that being tidally locked. It's exactly what our moon does with us. The changes would be slow, sure, but unbelievably transformative. The very first thing you'd have to get used to is that our concept of a day is just gone. A single day would now last an entire year. You'd have 6 straight months of scorching, continuous sunlight, immediately followed by 6 straight months of deep freezing night. The sun would just hang there, motionless in the sky, and then darkness, for half a year. And the next huge change? The world's oceans get a complete makeover. Remember that equatorial bulge from the spin? Well, without that centrifugal force pushing outwards, gravity would take complete control. All that water would just flow away from the equator and pull at the poles, creating 2 gigantic polar oceans and revealing a brand new supercontinent right around the Earth's middle. And our weather? It would be rewritten from scratch. No more Coriolis effect means all the complex patterns we rely on. Trade winds, jet streams, cyclones, they would all just vanish. Weather would become a much more simple and much more brutal system. Air would heat up on the sunny side, rise up, flow over to the cold, dark side, sink down, and flow back. That's it. A single massive weather loop. And there's a sneaky danger, too. The Earth's rotation helps churn the molten iron in its core, and that's what generates our protective magnetic field, our planet's shield. If the rotation grinds to a halt, that shield gets a lot weaker, and that would leave our planet and any technology we might have left dangerously exposed to harmful radiation from the sun.
So, let's tally it up. We've got extreme temperatures, rearranged continents, bizarre new weather patterns, and a weaker shield. After all of these massive changes, could anything, especially us, actually survive? That is the ultimate question, isn't it?
Well, if there's any hope, it lies in a very, very narrow strip of land. Life would probably have to retreat to what's called the terminator. That's the zone of permanent twilight between the baked day side and the frozen night side. Right there, in that little sliver of perpetual dawn or dusk, temperatures might just be gentle enough for liquid water to exist and maybe, just maybe, for life to hang on.
When you get right down to it, this whole thought experiment just proves a profound truth. Our planet's simple, daily spin is not some minor detail. It is one of the absolute pillars that holds up our world's climate, its geography, and its amazing ability to support life as we know it.
Thinking through all this really shows you just how delicate our little world is. We just saw what happens when you break one of the most basic rules of our planet. It kind of makes you wonder, right? What other invisible forces, what other perfect, delicate balances do we completely take for granted every single day that make all of this possible?